G'day guys, I've got a video today on a factorization method called completing the squares. We use this when we're factorizing quadratic trinomials, such as this one here. Now we're about to start a school year and inevitably lots of kids will run into problems with this particular method of factorization. And I've got a few theories on this, but one of my the standout contender so to speak, is that teachers explain a particular set of rules or a particular set of steps without explaining to the kids what the fuck they're doing. So today I'm going to try and explain how this method works and why all the steps are involved. So completing the square, what we're basically trying to do here is it involves creating what maths teachers like to call a perfect square. Now, I'm not talking about Steve Urkel or anything like that when I'm describing a perfect square. What I'm talking about here is a quadratic equation which can be expressed like this. X plus or minus, we'll say plus a particular number, let's call it a all squared. So this here is a perfect square. Now, if I multiply this bracket out, well, first, before we multiply it out, this looks like this. So it's a number multiplied by itself. So when it's multiplied out, we get so this is an example of a perfect square. Now, completing the square, what we try to do is we try and create a perfect square and then basically using a little bit of math, we almost bash it around a bit to make it fit the equation that we've been given. So the way that we create this perfect square is we use the a and the b terms in our quadratic trinomial. And for you guys who aren't aware of what those are, we've got quadratic trinomials sometimes are expressed like this. We've got ax squared plus bx plus c. So our a and b terms are these two here. So what we do is we use these two terms to create our perfect square, and then we basically smash around our c term to make it fit. Okay? So let me explain what I mean by using an example. I think it's easier for me that way. So what you can see here is when we multiply out our perfect square, we get this x squared plus 2a. So our b term here, to make it fit into a bracket like this, what we have to do is we have to divide it by 2. Because you can see when our term inside the bracket, when I multiply it out, it doubles it. So what we do is to get this one into a perfect square, I'm going to say this is going to be x take 1 all squared. Now what we can see here is if I multiply this out, I'm going to get x squared minus 2x plus 1. Now that's all well and good, but I've got a negative 15 here. So what we do is we need to turn this plus 1 into a minus 15. So what we do is we take away 16. So let me just put that in a bracket. Take 16. So the positive 1 minus 16 is going to equal plus 15. So what we can then say is to factorize this, we create our perfect square by halving that b term. And then what we do is we then subtract or add a number on the end to ensure that once we've multiplied out our perfect square, the c term is then made to match the c term in this. So whatever the difference is between the c term in our perfect square and the c term that we're given, we then have to subtract that or add it. So in this case, we're taking away 16. Okay, so that's the first one done. Now, what I'm going to do is I'm going to go straight into this second one. And to start with, what we have to do is we have to turn it into a trinomial form. So the way we do that is we're going to take the 35 over to the other side. So it's going to be x squared plus 2x minus 35 equals 0. So now we're in our trinomial form. So what we're going to do here is, like this one, we're going to halve that middle term. So we get x, not x squared, x plus 1 all squared. Now if we multiply that out, again, we're going to get x squared plus 2x plus 1. But we need to make negative 35. We have plus 1. So the difference between positive 1 and negative 35 is minus 36. So what we're going to do is, to this, I'm going to take away 36. And because this and this are equivalent, I'm just going to get my perfect square and sit negative 36 on the end of it. So this is going to be equal to x plus 1 all squared minus 36 equals 0. Okay, now here's the makings of a bit more tricky one. Now the reason it's a bit more tricky is because this b term here is odd. Okay, so we're going to use exactly the same method, but the mental math is a little bit more tricky. So to start with, what I'm going to do is I'm going to turn it into my trinomial. So I'm going to move the 18 to the left. So it's going to be x squared minus 7x minus 18 is 0. Okay, now we're going to make our perfect square. So I'm going to halve this number here. Now, when you're halving this, don't go to 3.5 because you won't be able to do the mental maths. Make sure that you always keep your b terms or any terms in these factorizations as fractions. So let me just make a little side note over here. I'll put it in red. So this is the side note. Always use fractions. Okay. So if we're going to halve this b term here, and we pay attention to this side note that I've created, we're going to go x minus, now 7 halved it is just 7 over 2. All squared. Now if I multiply out my perfect square, I'm going to get x squared, a double this term, so it's just minus 7x, and then it's going to be multiplied by the square of this, so we go plus 49 over 4. Now, I need to turn my 49 over 4 into negative 18. Now, what I can do first is I'm going to change, for my own mental maths, I'm going to change this now into a fraction over 4. So 18 times 4 is 72. So this is going to be 72 over 4. Okay, now, what I then do is I'm going to make 49 over 4 into negative 72 over 4. Now the difference between 49 and 72, 72 plus 400. Okay, so that's going to be 121. So what I have to do is I have to then minus away 121. 121 over 4. So you can see that like these ones become a lot more tricky with the mental maths, but you know, if you just do the working out on the side, like to make sure you don't make a mistake, you can still get through it. So we've got this 121 over 4 here. Like we said in the question previous, these two are equivalent. So to make this look like this, we then just go, this is equal to x minus 7 over 2 all squared minus 121 over 4. And that equals 0. Cool, so basically guys, what I've done in this video is I've factorized each of these things by completing the square. What most of these questions in a test will then ask us to do is solve them. I'll come to that in another video because all I wanted to do really today was to talk about factorization. Now, basically, let's just go through what we've done. First of all, when we're completing the square, we try and create a perfect square using the a and the b terms. Now, what I've done also in this video, because this is sort of an introduction, is all of the a terms are equal to 1. Now, I'll make another video where, or I already have other videos where the a term is not 1 and there are other parts to it, but essentially it follows the same method. What we try and do is using the first two terms, we create a perfect square. And then what we do is we almost multiply out our perfect square, see what the c term that gives us is, and then add or subtract the difference between that term and the term that we're given to make sure that our perfect square fits the equation that we're given in the question. It's not too hard, guys, but I'm just trying to give a little bit of context to what your teacher would have already explained in class to why the method that they ask works. So I hope it helped, guys. If it did, throw a like my way. If you have any questions, make sure you comment, and yeah, help me out and subscribe to my channel if you like it. It'd make me super stoked. Until next time, guys, enjoy the maths if you can, but I'll see you soon.